Great.
So welcome to this first evening of social and fun activities. We have two leading guests going to talk about mathematical puzzles. They are also going to do a session tomorrow about getting serious about mathematical fun, but tonight it's getting fun about mathematical fun. And they are Eliza Gallagher and Neil Calkin, and they're fresh off of a conference from Lisbon, Portugal. So we have world travelers, but they're both situated now in Clemson, in South Carolina, and welcome. So take it away.
Thank you.
Thank you. So you introduced us one way, but we'll introduce ourselves a different way. I'm FullDeck.
And I'm missing a few cards.
And let's see if I can make there we go. So we are, as Brian said, we're faculty members at Clemson University. If you want to know more about that side of what we do, talk is tomorrow at 5. We'd love to see you all there.
Yep, we're going to talk about some of the ways we're doing research with getting Sudoku into an educational context, and also the research on how you prove things about certain things about Sudoku.
Yes, good stuff. So, but tonight we're going to talk about constructing mathematical puzzles, and we're going to talk about there are lots of wonderful math puzzles out there. But for construction, we're going to focus on one particular kind of puzzle. And how many of you have played classic Sudoku before? This is where you're trying to fill in a 9x9 grid.
I have.
So here's an example of one. Great. And Missing Deck is going to pop a link to this puzzle in if you want. This is a classic Sudoku puzzle. So and it's one that we created. It is a very, very boring puzzle, or at least we think it's boring, because the techniques that you use to solve a classic Sudoku get stale fairly quickly. If you've solved a few Sudoku puzzles, either they seem really easy or you go for the hard ones, but it's still going to be a lot of the same techniques. Some really interesting techniques, but at least for me, repetitious, and it gets stale. So what we're going to talk about instead, what we like to solve instead, is mathematical Sudoku.
So this is sometimes called variant Sudoku, and it's basically the same rules as classic Sudoku, but with additional constraints added to the grid. So there may be conditions on certain cells having a given sum, or certain cells can't be consecutive, things like that. We'll give you examples of that in a moment. There are also 4x4, 6x6, and 8x8 versions used often to introduce some new constraints or ideas, or to construct simpler puzzles.
Yes. And because we're adding mathematical constraints, and we're not the ones who came up with this idea of variant Sudoku, but we've definitely jumped on the bandwagon, and we have introduced some constraints that became popular because of puzzles that we set and then spread to other setters. But because we're using mathematical constraints, there can be fewer given digits. In a classic Sudoku puzzle, you have to have at least 17 given digits in order to guarantee a unique solution. Often there are more than 17. 17 is the minimum. But you can have a mathematical Sudoku puzzle with no given digits.
Or even numbers. Arrows.
Oh,
you don't have to have any numbers in the grid.
Well, that's what I just said. No given digits or numbers at all.
Or numbers in cages and things.
Yeah. So we're going to introduce some of these ideas. First of all, with a 4x4 puzzle, just to
6x6.
Oh, 6x6. We're going to start with 6x6. Sorry, we'll get to a 4x4 later. Now, this is a puzzle that one of our students set, and as you can see in this 6x6 grid, so we're only going to use the digits 1 through 6. There are 3 given digits, and in addition to that, there are these pairs of cells that are surrounded by dashed lines, and the digits in those cells need to sum to the value that's shown in the upper left corner.
So those grouped cells are called cages.
And we're going to actually pop out and play this. And I
put a link in the chat if anybody wants to open a puzzle and play it themselves.
And we're going to pop over and let's see if it does share. Can you see the puzzle now on the screen? We're going to restart. We went through it earlier today to make sure that it all was good. Lumos is one of our students, or was one of our students. She's now graduated and off doing wonderful things in the world. So we're going to use these sum relationships. The fact that these two cells need to sum to 6 These two cells need to sum to 3, and those two need to sum to 5, and so on, to start getting additional information into the grid. So, lots of places that we could start, and we're going to try to do this whole puzzle without having to record intermediate deductions, and instead just think about where could a digit go and just place it right into the grid. And I'd like to start with row 6, because we have some restrictions on where we could place the digit 6 in row 6. Can't go here because it sees a 6 in the column. We can't place a 6 inside a 2-cell 5 cage because we would have to add a -1 to get to the correct sum, and we don't have a -1 available. So the 6 can't go in any of those 4 cells. So right away, I can place a 6.
What if you used modular arithmetic?
So actually that's the constraint that we introduced, was modular lines. We're not going to do an example of that right now, but on a modular line, any set of 3 adjacent digits along the line has to have 3 different remainders when divided by 3, and you get some really nice arithmetic with cages and with some other constraints. And
Cool.
there have been some examples, some puzzles that have set as well using modular arithmetic for sums in the cages and so on. So yeah, absolutely some really nice math that you can pull out right away. So.
Okay, now I'm going to ask, where can 6 go in box 4? And we can use that as an excuse to talk about how we label the boxes.
So in fact, let me turn on the labeling of the rows and columns so that we can talk about that. So in solving a Sudoku puzzle and communicating our reasoning, we'll talk about the rows from top to bottom. Row 1, row 2, row 3, and so on. And we talk about the columns from left to right. Row 1, column 1, column 2, here's a column 4. Now, we sort of wish that they were numbered from bottom to top so that they were more directly reinforcing coordinate notation, but we've got to go with what the community is doing. So, but at least we do.
And it agrees with matrix.
Yeah, this is true. It agrees with that. And we do at least get the idea of ordered pairs determining a location in the grid that can reinforce some of that kind of thinking. Yeah. So, and then boxes, you were saying something about boxes.
So the grid is divided in this case into 6 2x3 boxes, and we call those box 1.
One thing, I see what the bottom left corner has to be. The bottom left.
So hang on just a minute, Elliot. Let us talk through some of the words that we use, and then we'll be looking for some deductions for sure. Okay, so
the yellow box is box 1, the green box is box 2, the purpley one is box 3, blue is box 4, orange is box 5, and gray is box 6.
So when we talk about that, gives us a way to talk about where things are in the grid with lots of clear terminology.
So I was going to ask a question about where 6 could go in box 4, but since Elliot has come up with an observation, let's go with that. Elliot.
Wait, what do you mean box 4? I'm talking about the actual bottom left corner.
Yes.
The way there.
Yeah.
Right. So what is your deduction? What would you like to place?
Okay, column 1, row 6. So that has to be 5 because there's no 0.
Excellent. Yes, we can't put a 5 in either of those cages, so that's the only place left in the row for the 5. Excellent.
Yep.
So row 6, column 1 has to be a 5. Now you were going to say something about box 4. Now box 4, again, this was box 1. This is box 2. This is box 3. And over here is box 4. Now, what were you going to say about box 4?
Where can 6 go in that box?
Where can 6 go in this box? Let me highlight it for a moment. Thoughts about where 6 could go? Alan, you're grinning.
No, sorry, I have doing it parallel and I just haven't. What was the question?
We were asking where 6 can go in the box that we've currently highlighted yellow.
And Tova has said only in row 3, column 5.
Oh, excellent. So row 3, column 5. Tova, do you want to say why?
Sure. So it can't go in row 4 because there's already a 6 in row 4. It also can't go in column 6 because there's already a 6 in that column. And then it can't go in row 3, cell 4 because it won't sum up to 3.
Excellent. So we can place the 6. And those kinds of reasons, I mean, we will do a little bit more talking about what we do in class with students tomorrow, but those are the kinds of deductions that we can start
One
making.
thing,
Yes.
I noticed something. I noticed that row 4, I mean, no, column 4, with the middle two, those have to be 1 and 2 in some specific order, and that also means that and that also lets you narrow down no the columns 4 and 5 on row 6.
Okay, so yeah, we've got lots of things that we can see around the grid. Now, you said that the 3 cage had to be the digits 1 and 2 in some order, and the notation we use for that are these little center marks. These
Okay.
center marks indicate that the only values that could go here are 1 and 2. The only values that could go here are 1 and 2. And that certainly does have implications for the 5 cage. What else could we say? Let me ask this: where can 3 go now in box 6, in this one that we were looking at a moment ago, the yellow cells?
It needs to go on the top right corner.
Okay, and tell us why.
Because, for an instance, we have to the left side, it cannot be 3. And in the in the 9 case, we needed to sum 9, right? And for sum 9 with a 3, we need a 6, but we already put the 6.
Excellent. So that is the only place left for the 3. So this is how these puzzles proceed. We're not going to finish this puzzle. We're going to leave you to finish this puzzle, but that's how we can start to think about using mathematical relationships to drive the solve. And one of the things that's really important, we were talking about speed solvers before the session started, and speed solvers often just try things and go down a path, and then if it doesn't work, they backtrack, and then they try something else.
So
Go ahead.
Yeah, I'm not a speed solver. What is it we're trying to do in that yellow square? Make the numbers, the 2 things that are vertical add up to the same as the 3 that are horizontal?
So in each box, in these 6 yellow cells, we need to have the digits 1, 2, 3, 4, 5, and 6.
Yes.
Right. And so these 2 cells, just selecting those 2, I don't know if you can see it, there's a 3 in the upper left corner of this cage. So these 2 yellow cells, the digits in those have to sum to 3.
Oh.
So they have to be 1 and 2. We don't know which order yet.
And the 9 means they have to sum to 9.
Exactly.
But the number that goes under that 6 doesn't have to sum up to anything special. There's no restriction there,
Correct.
right? Okay.
But the 2 of them together sum to 9. Yeah.
Okay.
So in this box, they would have to be 4 and 5 in one order. We don't know which order yet.
Okay.
So let's do one more cage. One more piece of this puzzle. Let's do the 7 cage. Let's think about what happens with this 7 cage. We have to have 2 digits that sum to 7.
And that's the only restriction.
That's the only restriction, except that we only get to use the digits 1 through 6.
Agreed.
And we can only use them once each.
So if I just slam 5 and 2 in there, what are the consequences of doing that?
So if you have a reason for putting the 5 and the 2 in, then we put the 5 and the 2 in.
I don't have a reason except
then we're going to say we're not willing to put those in yet, right?
Oh, golly. Okay.
Yeah, because it turns out actually that articulating your reasoning for each step, each deduction that you make, is in essence a proof that the solution you reach is unique. So
Okay.
we do want to have solid logic between each deduction that we make and each digit that we place, because that's the way we know that our solution is unique and correct. So what are the ways that we can decompose 7 into 2 add-ins without repetition? Oh, Alan, you have the reasoning. Go for it.
Yes.
Okay.
It's based on that. So we can do it with 6 and 1, but we have a 6 on the bottom, so we can use it.
Can't use
We
a
can
1,
do
6.
it with a 3 and a 4, but we can do it because of the... So we must do it with a 5 and a 2.
Okay. So it
And
does have to be 5 and 2. Yeah.
Yeah. And additionally, the 5 is bottom, then the 2 is top for the another.
Yeah. So this has to be either a 2 or a 5, but it can't be a 5. So we get a 2 there and a 5 there. And you're exactly right. And now we can actually use this 5 to look down and say, well, we knew that this cell right here had to be either 4 or 5. And now we know it's not a 5. So it's a 4. And next to it is a 5 to make our sum of 9. So again, we're not going to finish out this puzzle because we want to show you how we construct puzzles, but we wanted to give you a sense of solving a puzzle. You have the link to this. So we'll have we'll say, you go finish this later. But right now we're going to actually, I'm going to go back over to our notes and we're going to give you a choice of what we set with. When we're constructing a puzzle, do you want to talk about this first?
Let me just copy this link over.
Okay.
And then I will talk about
Okay.
it. So when we're constructing a puzzle,
I
when
just
we're
solved
teaching
it.
other people to construct a puzzle, we tell them to start small. So start by doing 4x4 puzzles. Only one constraint. There are lots of constraints out there, and some people, when they start constructing puzzles, attempt to throw the entire kitchen sink at the puzzle. We allow our students to do that later, but when they're starting, one constraint. And to try and set with intentionality and use the constraints to push information around the grid. So we probably won't see very many given digits, but we will see constraints that are forcing certain types of reasoning from the top left to the top right, or the bottom right, maybe back to the bottom left. And we'll do an example of that in a moment.
And in fact, we're going to start by setting a 4x4. And we're going to let you choose from a limited range of constraints for us to use. So we can use the cages, which is what we just did. We just did an example. The puzzle we were solving used cages, where digits inside the cage sum to the value shown and they don't repeat. Or you could choose thermometers. Thermometers, along the thermometer, if we draw a thermometer, the digits have to increase from the bulb to the tip.
The one end of the thermometer has a sort of round bulb at the end. And so that's the lowest end, and the digits have to strictly increase as you move away from the bulb on the line.
Or you can choose Kropke pairs. And Kropke pairs, there are black dots, and the digits on either side of a black dot are in a 1-to-2 ratio. And there are white dots, and digits on either side of a white dot are consecutive. So we start to get to play with parity and doubling and things. So
curiously, Kropke is Polish for dots.
Yeah.
So Kropke dots are dots.
So we're actually going to give you a poll. We want you to vote for which constraints you want us to use. And that should be showing up for you, I hope. I've never actually used the poll. There we go. Okay, we've got votes coming in. All right.
How do we vote?
I don't know where the poll actually shows up. Is somebody who's voting, where do you go to vote?
It just popped on my screen.
It just popped up on your screen. Okay, and then just click on the choice you want. Okay.
Yes.
Thank you. And we have had 10, 12 votes. So that, I think, is all of us. So it looks like Kropke pairs are the winner.
Okay.
All right.
Kropke
Oh,
pairs.
unfortunate.
What's that? Unfortunate?
I voted for cages. My bad.
Well, no, that's okay. That's fine. We will, there'll be another opportunity to do this in a moment. So what we're going to do now is go to, and I have to figure out how to get there. Need to go to.
So you could click on the previous screen. Oh, you don't have it open.
Could want to go. I need to figure out how to navigate my world. There we go. Okay, so this is Sudoku Maker, and we have it set up already. Can you see it on this? Yes. Okay, good. I can see on yours. So we've done a little bit of pre-work. This is like where you go to you watch the cooking show and they say, okay, so chop all the onions, and now magically it's 3 hours later. So we've done a little bit of pre-work of getting this set up. But if you want to if you go to the sudokumaker.app, you're going to see a 9x9 grid. To get to a 4x4, you click on new and then change the size to 4x4 and then create. And I'm actually going to undo that just to make sure that I don't want to do that. I do want to be right there. There we go. Should have still got my rules in. I don't. All right. So You said you wanted Kropke pairs, and Kropke pairs, I'm going to click add constraint. And I'm going to scroll down. They get called difference Kropke dots, and I'm going to separately add ratio Kropke dots. And so now we're going to start adding things in. So Neil, why don't you choose first? What do you want to put where?
Okay, I'm going to put a white dot in row 1 between columns 3 and 4.
So a white dot right there. All right.
A white dot means that the digits on either side are consecutive integers. So it could be 1 and 2, 2 and 1, 2 and 3, 3 and 2, or 3 and 4, or 4 and 3.
So right now that gives us nothing.
Exactly.
Okay, helpful. So I'm going to add a black dot, and because black dots are much more powerful for a lot of reasons, I'm going to put a black dot right there. And so because we don't have 6 available, we can't have 3 on this black Kropke dot. So I now know that the only digits that are available to me are 1, 2, and 4. This has to be either 1, 2, or 2, 4 on this black dot. Don't know which one yet.
No.
Your turn.
But we do know there is a 2.
We do know there's a 2.
Because a 1 and a 4 doesn't work.
Yep.
Okay, so let's see. Can I put a black dot in column 4? Yes, rows 1 and between rows 1 and 2.
Column 4
Is that gonna
between
break?
rows 1 and 2. I'm not sure. That would mean, well, it would mean that we can't have a 3 on the Kropke dot. So this is also a 1, 2, 4. And now I know a couple of things now. I've used up 1, 2, and 4 in row 1. So that would make me have a 3
Breaks, I
there.
think.
Does it break?
Yeah.
It would also mean that this would have to be the 1, 2, because 2 and 4 aren't consecutive. So those would have to be the 1, 2 pair. That would mean that this would have to be a 4, which would mean that that would have
Yeah,
to be the
it
2.
breaks.
That would have to be the 1. And this would also have to be a 2. So Neil just broke the puzzle. So
Bad Neil.
naughty, naughty. So now we're going to go back and say your black dot there didn't work. So you lose a turn. It's my turn.
Okay.
Let's see. So I'm going to take this black dot out. And I'm going to.
So just a moment,
Yeah.
you're demonstrating the reasoning in building
Yes.
this, and
Yes.
you're doing the if then, and then you reach a contradiction, so you back away. Is this the kind of
Exactly.
reasoning you're trying to get your students to do, right?
Absolutely.
So-
Yes.
Okay.
And we need to take out the 1, 2, 4 on the other end because that was because
Oh,
of
right.
this
That was
side.
because of this. Right. So we don't know that anymore.
No, we don't.
We don't. So I would
Take the 3
like.
out.
Right, we don't know that at all. So we still have this, but that could be anything at the moment. I'm going to put a black dot on this side instead.
Okay.
And let's see if that works. Let's see if I can avoid breaking the puzzle. So now this chain has to go either 1, 2, 4 or 4, 2, 1. There's no other way around it.
Because the only one that has 2 neighbors that are a multiple of 2 away is 2. It can go to a half of it, which is 1, or double it, which is 2.
So we know for sure this is a 2. And then it's got a 1, 4 on either side. And now this white Kropke dot becomes really powerful
Exactly.
because the only thing left for the row is a 3. And the 3 isn't consecutive with 1. So that has to be the 4. And that has to be the 1. And so this chain of dots completely determines the digits in row 1.
And now we'll add some more constraints.
Some more clues, yeah.
Yeah.
Okay, what do you want to add? Your turn next.
Okay. Let's add a ratio dot between rows 2 and 3 in column.
Can I ask if there are no more constraints? None. Can you fill in the puzzle? I mean, is it?
That's a great question. So let me show you. We'll show you a tool on this. If I go to this button right here that's got a lot of numbers on it, it's going to tell me how many solutions exist to this puzzle at this moment.
Oh
12
my.
solutions. There are 12 solutions. So I do need more clues. So let's clear this back out.
So you want to make a puzzle that has a unique solution?
Yes, the goal
Okay.
is a unique solution that can be found by a human being.
Okay.
And fun.
And fun, yeah.
So I'm going to say a
Right
ratio
there?
dot no in
No.
in column 3
Column 3, right
between
there,
rows 2 and 3.
between rows 2 and 3, right there.
Yes.
Okay, so what can go on a black copy dot in a 4x4? Only 1, 2, and 4. But the 4 is used up. So this is going to have to be a 1, 2 pair. And that's only one spot left for the 3 in the column. Okay.
And now if you click on the number of solutions again,
We're now down to 6 solutions.
so we ruled out some of the solutions that were possible before.
Yep. So I'm going to do that though. Okay. It took away my numbers. So I'm going to put those back in because that's helpful to know what goes where. So I'm going to put in a white crop key, a difference dot right there. So now what goes in this cell has to be either consecutive with 1 or consecutive with 2.
And it can't be a 3
Yeah.
because the 3 in that box is in row 4.
So this is also going to have to be a 1, 2 because the 3 is already used up. And that means I'm going to get a 4 right there. And it also now means that this has to be a 1, 2. So now what?
I can finish row 4 now.
You can finish row 4. Okay,
That's
go for it.
because I know that 2 cannot go in column 2.
Ah,
So it has to go in column
that
1.
has to be a 1 and that has to be a 2. Excellent.
And so now I know that we're going to have to somehow place 3 and 4 in row 3. And I think if we put in a white crop key dot between columns 2 and 3 in row 3.
Between right there, that's going to be a
2
3,
and
4
3.
between. Oh, right there. You want it there. I was going to put it here, but there works.
It works.
There works. Okay. So this cell has to be either consecutive with 1, which would have to be a 2, which doesn't work, or consecutive with 2, which is either a 1 or a 3, and the 1 doesn't work. So that means this has to be a 3, that has to be a 2, that has to be a, oops, well, the way around, that has to be a 2, that has to be a 1. So now that's a 2, and that's a 1. And now we know that that's a 4, that's a 3, and that's a 4. So this puzzle should have a unique solution and one that we should be able to find. So let's just count and make sure with this and this, the checker says, yep, that's a unique solution. Now we did that not by, letting the machine tell us that, but by thinking through what the logic was that sort of pushed around the grid.
Now, one of the important things here is we need to have rules for these puzzles.
Yes.
So that the people solving them know what the rules are. And we have a page of rules that we'll show you later. If you choose to start learning to set puzzles, we strongly recommend using a standard version of the rules text. We've worked quite hard to make the rules clear, and they're sort of community-wide, they're fairly standard.
So the rules for 4x4 Sudoku and then crop the pairs. So digits separated by a black dot are in a 1 to 2 ratio. Digits separated by a white dot are consecutive. And we need a title for it.
I suggest Simiode 4x4.
Simiode 4x4 demo, maybe. Is that okay?
Yep.
All right.
Great.
So we update that. And now when we click on play, we're going to get a link to the puzzle so that we can play it. And we're going to copy that. We're going to paste that into chat. And what we would like you to do is test the puzzle yourselves. Make sure that you can solve the puzzle, because after you set a puzzle, it's really important to make sure that it is actually humanable. Now for this 4x4, as we were thinking through the logic, it should be that it does in fact solve nicely, but take a moment, go through it, see if the logic makes sense. When you feel satisfied that it is a humanable puzzle, give us a thumbs up or a solved or something in chat to let us know that you got it.
This is a very important part of creating puzzles, is testing to see that they are solvable and whether they're fun.
Yeah.
Now, this is a small puzzle, and it's not likely to be challenging enough to be a huge amount of fun, but this is one that we would introduce people to crop key dots with, for example.
Yeah. And we set a puzzle earlier today that we set it and then we sat to test it, and it took us 40 minutes to get through the test of making sure that each step
That was
was.
a 9x9
It
puzzle.
was a 9x9 puzzle. So we're actually gonna take a moment, and I'm actually gonna set up a new poll while people are still solving the puzzle. Some people are done, but I'm gonna set up a new poll. Oh, Stein's here.
Oh, good.
Excellent. Because it seems as though some of you really want to dive into setting puzzles yourself. Some might want to set more with us. I'm not sure that I can set up a poll while I'm sharing. It does look like folks are finishing out on solving. Excellent. Okay, so we're going to give you a choice next. So we have several of our experienced setters here with us. So Elsie and Ben and Christina Foley all are experienced setters. Actually, so Ben, I don't want to put you on the spot for that. I know that it may have been a while since you've done some settings. So we'll say Elsie and Stein are the real leads there. If you want to go play around with setting your own puzzle, then we can set up a breakout room for that, and they'll be there to help. Are you good with that? This is on the fly. I didn't warn you about this ahead of time. Are you okay with that, to sort of help people with logistics? Okay, I'm seeing a nod from Elsie. Okay. And then in the main room, we will set a 9x9, again with constraints that you choose, but with a lot of input from you of where should the next clue go. So first poll is going to be, where do you want to go next? And if you move to your own breakout room, we'll send Stein with you, and folks who want to stay here, we'll start setting a 9x9 soon.
I will say that we do have a page of links on the PDF of our slides, which we're going to put in the chat near the end. And there are links to all of the tools that we use today to set these puzzles and to play them. And also links to a couple of books that we have produced of our students' puzzles, which have information on how to use the solving software.
All right. We don't have responses from everybody, but we'll go ahead and close now. We've got we've got 2 books out, a third about to come out. Stein, we haven't sent it to the printer yet because we're still working on one thing. So Stein has several puzzles in the most recent book, as does LC. So yeah. So we will go ahead and open the breakout rooms, and we're going to end the poll. And what we'll do is, I'm actually, rather than sending people automatically, we're just going to create a breakout room, and the person, whoever wants to move into that to set a puzzle, you can choose to go there. And so we're just going to create that one breakout room for folks who want to go there. All right, so it is now open. So if you want to go set your own puzzle, you can move there. And for everybody who stays here, we're going to put up a poll for you to choose from among those same constraints, but this time we will take the top 2 vote getters so that we're going to be able to use 2 constraints, either cages and thermos, or cages and Kropke pairs, or thermos and Kropke pairs. So vote for your favorite. You only get 1 vote, but we will take the top 2 vote getters for our constraints. Oh, thermometers running away with it.
So 100% answered. And it looks like it's thermometers and cages. So
right.
We've seen Kropke pairs.
Excellent.
So we'll now see thermometers and cages.
Thermometers and cages. Actually, we do have one more person who could potentially vote, but I think. All right. No, that's it. That was, yep. Okay, so 11 of 12. We're good though. Thermometers and cages. So let's see. Are we seeing? There we go. So now we're over here, and we need to again add our constraints. So we're going to add thermometers, and we're going to add cages. In the variant Sudoku community, it's often called killer cages, but because we do a lot of work with students out in elementary schools, we felt like the word killer was probably not the optimal word to be using, so we just refer to them as cages instead of killer cages. But you may have seen killer Sudoku before. And let's just check on the breakout rooms. So yeah, so anybody who wants to move to setting your own puzzle, you can go ahead and join that whenever you're ready. And then Stein, if you'll just keep an eye on that, and if anybody does join it, you join them, that'd be great. All right. So thermometers. I'm going to start by putting in a long thermometer because
Okay.
that gives us a lot of information. So maybe an 8-cell thermometer wrapped around in that box,
Okay.
because that tells us some things. On this thermometer, the digits are going to have to strictly increase. So we can't start, for example, as high as a 3, because if we started with a 3, even if we minimized, we get 4, 5, 6, 7, 8, 9, we're out of numbers. Right, so this can only be a 1 or a 2. And I've got controls all over everything that I need to get to. In Zoom is not the friendliest of things for this. So that can only be a 1 or a 2.
And the next digit can't be higher than a 3, and it can't be a 1. So it's a 2 or a 3.
And a 3 or a 4, a 4 or a 5, and a 5 or a 6, and a 6 or a 7, and a 7 or an 8, and an 8 or a 9. And one of the things that I know is that the 9 has to be in one of those 2 digits.
Okay, I'm now going to suggest a thermometer in column 8, going from the bottom all the way 8 steps. Nope.
I didn't mean to go that far. I heard the 8, but okay. So, wow. That's going to do a lot of work on this puzzle. So what value could this take?
But will it break?
Yeah, it might. We know some things now. This can't be a 9. So it has to be an 8. And then a 7, a 6, a 5, a 4, a 3, a 2, a 1. That is our only choice for that thermometer. So his thermometer was big and powerful.
Yep.
Okay.
And it also looks left.
Oh, it gives us the 9 there. And the 7
7.
comes out here and gives us an 8, and it gives us a 6, a 5, a 4, a 3, a 2, and a 1. So what goes in there? A 7. So those two thermometers in combination forced a lot of information. Now, we're going to intentionally set a puzzle that's pretty forced, and we can see the logic quickly because we want to have time to get done with it and have it
The
tested.
question,
Yeah.
thermometers just have to be increasing, not consecutive,
That is
right?
correct.
Okay, sorry.
Yes. No, and that's a really subtle point that is often you really want when you're first introducing thermometers to force a situation where they're not consecutive so that comes to light.
So the 6 and the 8 are not consecutive in this
Exactly.
one, so it is an
Exactly.
example.
So now we're going to invite you to either unmute or pop something in chat and suggest either a thermometer or a cage to add, and we'll think about what that does to the puzzle.
Can you add a cage to the all the way at the bottom right corner that adds up to that adds up to 8?
So which cells do you want
That
to
eight-
include?
The bottom right and the one just above it.
Those two.
Yes.
Let's
You
think
could
about
try.
that. If that were an 8 cage,
Oh wait, hold on. That would only leave what? No, that wouldn't be impossible.
exactly, the puzzle would break because
But
we
it
have
would
to
work
either,
if it was a 9.
but it would work if it were a 9. Yeah, so let's make it a 9 then. And that's going to tell us that these two cells have to be 4 and 5.
And we don't know
We
the
don't
order,
know which.
and that's okay.
But I like the idea of putting in an 8 cage, and let's make life sweet and easy.
That won't work.
That won't work either. Never mind. That was
Well, you could put it next to the 2.
I could.
Could you just go back to the upper left square? There's no other constraints on those numbers except that they be in that sequence. For example, the column sums are all different,
Correct. Correct.
but 1 through 9, all of them have to appear in the
That's right.
columns. That's the only external constraint. Okay.
Exactly. Yeah,
Okay.
we have to have all of the digits 1 through 9
Got
in that
it.
box. Yep.
And in every
And
row,
in the row.
in every column.
And every row and every column. Okay.
Yeah. So, I want to add a cage. I'm going to go back up to the top of the grid. And I'm going to put in if I can do that, I would like to put in a 7 cage like that. Now, this puzzle may not be aesthetically as pleasing as we might like. We like to put a lot of symmetry in, but right now we're playing more with the how can we force information around. Why do you suppose I might have put a 7 cage there? A 3-cell 7 cage. Remember, digits cannot repeat inside cages.
And you see a 4 in the top zone.
Uh-huh.
That well, it give us more information, but I don't know what else apart
So-
of that 4 up.
So one person has sent a DM saying that the 7 cage has to be 1 plus 2 plus 4. Oops, I didn't mean to undo it.
Ellen,
Right. It has to be 1 plus 2 plus 4. It's the only way to make 7 as a sum of 3 non-repeating digits. So we know we have to have 1, 2, 4 in here. And this one sees a 1 and a 2 in the row, so that has to be our 4. And then these two have to be 1 and 2. So your turn again from the crowd. What shall we put in?
We just can't add a thermometer starting at 6. No,
Starting here?
the other 6
Starting here.
and going back down for like length 5, just arbitrarily. I don't, that is that you try something and
So if
realize
we-
it doesn't work, right?
Yeah, so if we wanted to add a thermometer that started here, I can actually do overlapping thermometers. I need to add a second instance of
but-
Oh, I'm
thermometer.
sorry.
We-
Okay.
We generally don't do that.
Okay, I
generally
understand.
don't
No,
do that.
that's okay with me. But I mean,
Yeah.
if I wanted to put a thermometer down in the bottom box,
Sure,
say something like
Like that?
simple like that. Yeah.
yeah,
we-
absolutely.
We could go ahead and it has lots of options. Well, it can't have a 4, right?
Yeah, the smallest this can be, it can't be 1, 2, 3, 4, or 5. So this is
Gotcha.
at least a 6, and it's at
Okay.
most a 7. So it's a 6 or a 7.
Okay.
That's at least a 7 and can't be more than 8. So it's 7 or 8. And this is at least an 8 and can't be more than 9. So it's an 8 or 9. So that's actually a really nice thermo to put in. It's a very, very much narrows down possibilities.
Okay. So that's allowable.
Oh,
It
yeah,
it hasn't contradicted anything. It hasn't been proven impossible.
that's right.
But
But
let's
we-
check that
but-
it's not impossible.
But we may throw it out later, right? I mean, for some other reason. I mean,
We might.
We might.
okay.
Yeah,
Oh,
we can
the-
come back and edit things out if we want.
Okay.
And I would really prefer not to
Okay.
check the number of solutions right now, just because then we have to go back and re-enter all of the
Oh,
things
right,
we
right.
figured out, and that's a pain. So okay, so let's think about trying to force something specific. So right now, if we think about 3s in this box 7 over here, we know that 3 can't be in any of these cells already, just because it sees a 3 in the row. That 3 locks out those, and this 3 locks out these. So if we wanted to figure out where the 3 would go among those 4 cells, how could we do that? What kind of constraint might we put in that would force a 3 into one of those positions?
So I'm seeing 2 people saying another 4 cage.
Okay. So we could put in a killer cage that sums to 4. So say right there, would that work?
It wouldn't work because of the 1.
In the
Ah.
bottom.
So let's think about that. So this would have to be 1 and 3. It can't be 2 and 2. This 1 would tell us which one could be the 3.
Yes.
So that could work.
Oh, wait. No, yeah, that does work.
Sarah pointed out a problem in the chat.
Okay. Great. What is, let's see.
Can't put a 5 in top right box.
Oh,
yes. So the puzzle
sure,
is broken.
it is broken. We should have done a count. Excellent.
Yeah.
So that means we need to go back. Let's undo. So let's
Well spotted, Sarah.
Very well spotted. So we're going to go back to where we didn't. Now, that problem got introduced when we put this 9 or when we put the 7 cage in. That locked out the spots for the 5. So we could, at this point, say, let's not put that 7 cage in. Alternatively, we could change this sum so it's not forcing a 5 there. Okay. I think I really like this 9 cage, and I really liked the thermo that you suggested, Brian. So let's put that one back in. So we have the 6, 7, 7, 8, and 8, 9. But yeah, we have a 5 in one of those 2 cells now because the 5 is locked out there and the 5 is locked out there. So let's try to force that. Let's see if we can make that happen. What might we do that would place a 5? Figure out. Force the 5.
You could put a
And then
thermometer going from 5 up to 6.
So we could put a thermometer, but I think there would be a lot of flexibility.
Could go
With a
from
cage.
5.
Yeah, just a thermometer. I think a cage might be more helpful here. And I think I
Okay.
heard somebody suggest a value for the
A
cage.
cage that zooms 11.
To 11, okay?
Yeah.
So 11, well, it can't be 9 and 2. It can't, oops. Get rid of that cage. It can't be 8 and 3. It can't be 7 and 4. So it will be 5, 6.
Don't know the
But we
order,
don't know the order yet.
but that will force the thermo in box 9 to be resolved.
Oh, yeah. That'll take the 6 out down here. And that'll make that 7, 8, 9. And it will give us a 6 right there. Okay.
And it will give us a 4 in box 3.
Oh,
We-
right. Because the
Okay,
4 can't go in this column, and so it has to go there.
one of my tasks as moderator is just tell you something about time. So
Yeah, we
let's
only
say
have 9
no,
minutes, yes.
no, yeah, that's, and we really want to be fair to the next one. But the point
Absolutely.
is that what you're doing is introducing us to a tool to make
Yes.
these, and that
Exactly.
tool has these options.
Yes,
And if we were to sit down as individuals, we would be doing this kind of logic, try this,
Exactly.
back up, and so forth. But when the person doing this, we would then put this in the newspaper, right?
you could. It's
No, no,
actually hard
no,
to
no,
get
no.
newspapers interested in variant Sudoku.
No, whatever. But I mean,
Yeah.
we would publish this.
Yes.
And would the published version know that in upper box 1 there's the thermometer? Would they be gray,
Yes.
indicating
So
thermometer and cells, right?
if we were to just export this right now, the information we've already put into it is showing up in the puzzle that it gets exported.
Yeah, so those are
Yeah.
prompts to me
Yes.
as a solver that says, you're going to put numbers in, let's say, column 8, and they better be a thermometer.
Exactly.
Okay.
Exactly.
And so that puzzle is going to look like a bunch of thermometers, cells, and the dots.
That's exactly right.
Okay. And you were saying this puzzle was constructed using thermometers and one other
Thermometers and cages, yes.
cages. Yes.
Yeah.
Okay.
So, and thank you for redirecting us, because there are some things we want to show you. We would set all night, and this is great fun. But we do want to. We're going to send you a PDF of the slides, which include sort of some resources. So all of these links are there, but we're going to talk you through what the resources are. Our website, missingdeck.net. We have over 700 puzzles there. And all of them are playable online. And there are different levels of difficulty. We have about 150 more that we need to load. A lot of the student puzzles from the last 2 volumes of puzzles, we haven't loaded yet. But the student puzzles are in the 2 links for Signet Sudoku. There's Signet Sudoku Volume 1, Signet Sudoku Volume 2.
You can buy the physical
In
books
hard
if
copy,
you wish,
they look like this.
but you can also download the PDF, and the PDF is free and the books are $10.
Yeah.
So we recommend downloading the books.
Yeah.
You can click on the links in the PDF and it'll open the puzzle in the solving software. The books also have information about how to use the solving software and some suggestions for how to use pencil marks in the grid. So there are two different types of notation that we recommend, center marks and corner marks, and we have different rules for when you put them in. They have different meanings, and we go
Yeah.
through that extensively in the books.
So I would assume that only arrogant people do these with pen, right?
They're actually really hard to do with pen.
Yeah,
I can
Yeah.
imagine.
definitely. The setting software that we were using tonight, Sudoku Maker, was created and is maintained by somebody named Sir Zemek. And the link to that is in here. The solving software that we were using when we exported the puzzle out is Sudoku Pad, and that's created and maintained by Sven Neumann. And so a big shout out to him. He's
Yeah, it's wonderful software.
absolutely wonderful software. When you set a puzzle, we hope you will go set puzzles. If you want to send them to us, we will test them and give you feedback if you would like.
Okay.
And you can send them to our email. And then the phrasing, the standard phrasing for the constraints, we'll show you that real quick. This is what we have on our website, and we do update it
Oh.
occasionally to keep in line with the community. But you can see there's a ton of different
Yeah.
constraints that
It
get
gives you an
used.
idea of how many
How
different
many
constraints
different
there are.
constraints there are. But again, our advice, start small, start with one constraint and test. So,
Okay.
and
So these are not ordinary Sudokus. These are rather refined with these constraints, which are showing up as gray or some coloration.
Yeah.
Okay.
Yeah, we have set maybe one or two classic Sudokus, but that's it.
that's it. Yeah.
Almost all of the Sudokus we set have variant Sudoku constraints.
Okay.
Yeah. And thank you so much all for coming. This has been a lovely way to spend a Saturday evening. So, bye.
It was so fun. Thank you guys for doing this.
I'm so
Oh,
glad
you're
you
welcome.
enjoyed it.
Yeah.
Bye. This was great.
Bye.